computation.
In the given problem, there is a survey line. To that survey line, there is a irregular boundary on either side. For example, a survey line is there, maybe something like this, and you have a irregular boundary, right? And a survey line is starting at 0 and it is ending at 80 meters, and to this irregular boundary he has taken it as offsets, which means at 0 it is 2.5, and at 5 meters it is 3.5, 3.8, at 10 meters it is 4.6. Likewise, at 80 meters the offset is 2.2. If these are the set of coordinates starting from O1, O2, O3, these all are given to you, then how much would be the area? You have to use trapezoidal rule and prismoidal rule. So we would first write down the ordinates, then certainly we will substitute the trapezoidal rule and prismoidal rule and find out the area, right? So we will write down the given data first of all. Given data, ordinate number 1, how much? 2.5, ordinate 2, 3.8, ordinate 3, 4.6, ordinate 4, 5.2, ordinate 5, 6.1, ordinate 6, 4.7, ordinate 7, 5.8, ordinate 8, 3.9, and ordinate 9, it is 2.2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 ordinates have been given to you. So this 9 value is a odd value, not an even value. So when we have discussed in the last class that if you have a odd number of ordinates, then prismoidal rule is the best method to apply. However, trapezoidal has got no limitations for it. You can apply this equation for any number of coordinates. Now how to calculate this is, so we have trapezoidal equation. Let us write down the trapezoidal rule. Now what is the trapezoidal rule says? Trapezoidal rule, area is given by the common distance divided by 2. What is D? D is common distance divided by 2. Sum of first ordinate and last ordinate plus 2 times remaining ordinates, that is O2, O3 plus O1 up to On minus 1. This is the trapezoidal rule. In order to apply this trapezoidal rule, one thing is common is that this D is notably called as a common distance. So which means ordinate, the distance between the ordinates is common in entire the offsets. If you notice here, the distance is not common. You have to notice that first of all. Understand the given data. Now if you happen to see 5 meters change, 5 meters change, 5 meters change, 5 meters change. Up to here 5 meters change is there. And after that we have 20 to 10. 10 meters, 10 meters, that's it. Up to here there is 10 meters. Then afterwards you have 20 meters and 20 meters. So you have 3 sets. So you have to calculate 3 sets of area because the common distance is varying. Then afterwards you have to add them all. So let us do for the common distance of 5 meters. So I am putting like A1. I am taking common distance as 5 meters. 5 by 2 For the first 5, these are the distance and offset values for the common distance of 5. So this could be ordinate 1, 2, 3, 4 and 5. 5 ordinates we have to consider. So first ordinate is 2.5 and the last ordinate is 6.1 plus 2 times the remaining ordinates is 3.8 plus 4.6 plus 5.2. This will give you a value of 89.50 meters square. Right. Similarly, for a common distance of 10 meters, 10 divided by 2 in trapezoidal rule. So we got 1, 2, 3. There are 3 ordinates here, right? So 10 by 2 plus the first ordinate being 6.1, second ordinate being, last ordinate being 5.8. Plus 2 times the rest ordinate is only 1 we have got, so this could be 4.7. So the answer to this is 105.6 square meters. Now we have got A3 where the common distance is 20 meters. We got 1, 2, 3 ordinates whose common distance is 20 meters. Now 20 by 2 divide and multiply by first ordinate plus last ordinate plus into 2 into the first ordinate is 3.9, and if you happen to calculate this you will get a value of 158.0 square meters. So total area is given by 89.50 plus 106.5 plus 158 will give you a value of 354.0 meters. Now using trapezoidal rule we have calculated it. Now in the same way we have to do for prismoidal. Prismoidal rule is also called as parabola rule or Simpson rule. So as per this rule, area for different ordinates being having a common distance is given by the common distance divided by 3, first ordinate plus last ordinate plus 4 times even ordinates plus 2 times odd ordinates. So for the area 1 where the ordinates are having the same common distance of 5 meters, we calculate first in the same way. So this will be 5 by 3. So the common distance of 5 meters. So we got how many? 1, 2, 3, 4 and 5. So the first ordinate being 2.5, the last ordinate being 6.1 plus 4 times even ordinates are 3.8 plus 5.2. This is second and this is fourth, and 2 times being odd ordinates, third, only third, right? So you'll get a value here, and A2 being denoting common distance of 10 meters. So you get these three ordinates are having 10 meters of a common distance. So this could be 6.1 plus 5.8. This is an even ordinate. So 4 times even ordinate is 4.7. So there is no odd ordinate because we got 3 there. So that's it. Similarly, A3 is given by 20 divided by 3, 5.8 plus 2.2 plus 4 times 3.9. So, if you happen to calculate total area from prismoidal rule, the value will be less than that if you happen to notice. The value is less when you compare to the trapezoidal rule because the lines which is joined by the ordinates in prismoidal rule is considered as a parabola where that is a straight line. Now, we will learn how to calculate the volume. Now, we have discussed how to calculate the area. So, area in terms of square meters we will get. Now, we will calculate how to estimate the volume if you are given this certain data. So we'll do one problem. I'll dictate the problem. Please note down the problem and subsequently we will solve it. Okay. So the problem says the width of the formation level. The width of the formation level of a cutting of a canal. The width of the formation level of a cutting of a canal with side slope of 1.5:1. 1.5:1 is 5 meters. Is 5 meters. So there is a continuation to that problem, but I am writing down the given data for the time being. So given data, breadth is given as 5 meters. That is we are denoting with B, and side slopes we are denoting this as 1.5:1, but we denote with S:1. This data is given to you. So from here we can note down that your S value is 1.5. Simple. Right. Continuation to that problem. There is no cross slope in the direction. There is no cross slope in the direction across the length of cutting. Across the length of cutting. What does it mean it is meaning that the cross section is the level section, not the 2-level section, not the 3-level section. So the statement says there is no cross slope in the direction across the length of the cutting. And if I am traveling, then there is no cross slope in the direction along the cutting. So in this direction there is no cross slope, it is exactly level. Right? So he is telling that the ground level is level and we got a formation width and we got the side slopes as 1.5:1. This is also 1.5:1. and this breadth is given by 5 meters, and we are supposed to calculate the area and volume, and this height will be varying. Calculate the, so there is no cross slope in the direction across the length of the cutting. Continuation with that. Calculate the volume by trapezoidal and prismoidal rule. Calculate the volume by trapezoidal and prismoidal rule. The total volume of cutting, over a length of 150 meters, total length, over a length of 150 meters, if the central height is, this is the central height. If the central height is taken at 25 meters interval, at the rate 25 meters. This height is taken at every 25 meters interval, which means 0, 25, 50, 75, up to 150 meters. Or total volume of cutting over a length of 150 meters, if the central heights in meter at 25 meters interval are 3 meters, 3.063 meters, 3.126 meters, 3.189 meters, 3.252 meters, 3.315 meters, 3.378 meters. So 3.063, 3.126, 3.189, 3.252, 3.315 and 3.378 are the heights at 25 meters interval. If you want, you can calculate this total length will be 150. 0, 25, 50. 0, 25, 50, 75, 100, 125, 150. So from 0 to 150 meters is been taken. Now you need to calculate the area. Instead of coordinates here, areas will come. Instead of D, interval of 25 meters will come. Because area at first 0 is this much, 25 is this much, 50 is this much. If you multiply with the length, then you will get the volume. Area multiplied by length, you will get volume. Meter square multiplied by meter. So we will calculate the area. A1 is given by, we know for a given figure, if this is B plus what S times H, and sorry, this is 2 times, and this is B, and area we know equation as B plus SH into H. This is the equation. Now we will use the same equation. B is 5 meters. This will not change at all. S is 1.5 meters. This also will not change. H will be varying. So for the first being H is 3 and next is 3. You will get this area as 25.80 meters square. Similarly, A2 is 5 plus 1.5 multiplied by 3.063 into 3.063, that is 26.573 square meters. Similarly, calculate for A3 up to so on. How many will get? You will get A6. Fine. Now when you get all these values, now we need to use trapezoidal rule first. Okay. So trapezoidal rule says volume is given by, right? So common distance divided by V2. We have a common distance of 25 meters. Right, then we got first ordinate, now we should call as first area. Next we got last area plus 4 times remaining areas, that is A2 plus A3 plus so on up to A5. And if you suppose to calculate the area using trapezoidal rule, you will get as 4224.563 meter cube. Now please verify this value from your side. Now similarly, Simpson rule says I said that Simpson rule is only applicable or gives an accurate value when you have odd numbers, but we got even. So I do say that when you have even number of ordinates or areas, then for the last 2 hours you have to use either mid ordinate or pattern. So we will use from here to here the Simpson rule, thereafter we go for that. So we'll divide it as V1 and V2. So V1 being the first 5 ordinates and V2 being 5th and 6th areas. So V1 is given by D by 3 into first ordinate plus last ordinate plus 4 times even ordinates plus 4 times even ordinates are what? 2, 4, correct? Then 2 times odd ordinates are A3 and A5. 1, 2, 3, 4, 5 and 6. Now if you happen to calculate this, sorry, we have to substitute here 5, right? So 5 and here nothing. For the first 5 areas, please calculate the area, right? Then for the last 2 ordinates, using mid ordinate you can do it. So the A5 plus A6 by 2 multiplied by 25 you have to do. So what did I do? I have taken A5 area and I have taken A5 area and I have taken A6 area and I have done average, then I got mid average, then I multiplied with the overall length, that is 25. You will get a value in cubic meters. Now total volume capital V is given by V1 plus V2. So add this in order to get the exact value. In this video, we are going to talk about theodolite survey. In the previous units, we have discussed how to calculate the distance between 2 points. Like if you have a point here, A, and if you have a point B here, then how to calculate this distance using chain and tape we have discussed, and if you know the knot, now what is the bearing of this in order to plot it, we also discussed in compass survey. Now at every time if you have more survey lines, the calculation of compass survey becomes more difficult and hectic because the compass survey has got so many errors, local attraction, where you need to identify it and where you need to correct them. In any closed traverse, if you have 5 sites, we assume that we predict that one of these side is having an exact forward bearing back bearing difference of 180. But what if that side also is attracted to something and we got an error from it? So all the 5 sides have been under local attraction and not any one of them bearing is correct. That's a big challenge for us in order to plot our survey. So in order to rectify it, in order to use the natural principles of magnetism, so we have an instrument called theodolite, which exceptionally only used in order to calculate horizontal and vertical angles. So if you have another point, say for example I got C here and I would like to calculate the angle from here to here. Now this makes very simple, like you have a protractor, right? We all know how protractor looks, right? So this is 0 degrees, this is 90 degrees, and this is 180 degrees. Now, what if I able to place protractor here, and I could easily calculate the difference, the angle made by ABC. If I have protractor. So in a similar way, an instrument is used in a protractor way so that you can orient one of the side as 0, and thereby you can, if this, you have 2 circles there, like I have 2 hands here. I got 2 hands here. One is the bottom circle, other is the top circle. Now I got 2 hands. If I have placed them one above the other, now I have placed them in such a way that these both match at 0 degrees. And when I start rotating this, I could read the angle because this is set to 0 and 10, 20, 30, 40, 50. So I can read the angle if I have a scale there. So that is how the theodolite is designed. So we got there 2 circles. One is called as a vernier scale, other is the main scale. In main scale we have 0 to 360 degrees, whereas top scale we got only vernier from 0 to 20. Sorry. Like we have in vernier calculus. So this is exceptionally used in order to calculate the horizontal angles and vertical angles. This is exceptionally used in the calculation of deflection angles. What is a deflection angle? When you have an open traverse, right? Now, if you are going through a line and suddenly that line has been changed, the traverse has been changed, now it has been deflected to a certain angle. Now, what is this deflection angle? You can plot it. So, for this ABC, the deflection is AB should proceeding like this, but AB line has changed. So, this is called as deflection angle, which is commonly denoted by phi. So that angle can be easily calculated. If you know the knot symbol, magnetic bearings will also be very easy. Using trigonometrical principles, you can calculate vertical height and horizontal distance of any point without using tape. How much the far the distance is? All that you need to have is the theodolite with the stevia and along with the diaphragm. And if you have that, then you can calculate vertical distance of the object and the horizontal distance from where I am standing and difference between elevation of these 2 objects also using theodolite. So theodolite is a very good instrument which revolves the entire area of the field of surveying. where we could accurately set out a point of required angle. For example, to dominate all buildings, what we do is we have 90 degrees, right? Exactly, the angles could be 90 degrees. If I want to set up a building, now if this is, say for example, 30 meters or within the tape limit, we can easily plot it. But what if this building is 300 meters? Now, even if a small change, if this is the perfect 90 degrees line, and even if a small change is there, the error gradually increases, and you have a big error when the length goes on increases. Now, this makes very complicated when you have too many errors in a building. So, theodolite compensated these errors because it is specially designed to estimate the angles between 2 points. Thereby, you can apply trigonometrical principles to be able to calculate vertical and horizontal distance between 2 points. And typically, your instrument looks like this. Now, you got 3 axes there: x, y, and z. I have designated it, but in surveying, Z is always taken as a vertical axis, and that is, this y axis is often called as a Turnian axis. And for example, if this is my telescope, for example, if this is my telescope is fitted to this, and if I happen to draw a line, something like this is called as a horizontal axis. You can take a look there. This is called as a horizontal axis. And if I drop a perpendicular like this, then this is called as a vertical axis. Horizontal axis, and this is called as a vertical axis. And you can also draw a perpendicular here. This is called as a Turnian axis. Right? This is horizontal axis. This is vertical axis, and perpendicular. This is called as a Turnian axis. Now if I am rotating my telescope in this direction, so which axis I am rotating? I am rotating in Turnian axis, right? And if I am rotating in this way, then I am rotating in vertical axis. So I am rotating in vertical axis, I am rotating in Turnian axis. So these are the things which you need to remember very carefully when you are defining the definitions of it. Okay. So let us now discuss about few definitions, right? So basically there are 2 types of theodolites. One is transit theodolite, another one is non-transit theodolite. Now if you have a telescope and if you can able to rotate something like this in this axis, this is the vertical plane. Plane is a piece of paper. Now if you can able to rotate in vertical plane, then that is called as a transit theodolite. And if you can't able to rotate, it's fixed, and you can only do something like this. I can't able to rotate this. I cannot bring my cap to here by rotating because it is non-transit. So what I do is I rotate something like this, right? So that is called as a non-transit theodolite, where you cannot rotate the telescope in vertical plane. So typically, if you see from eyepiece to the objective, so this is called as an eyepiece, and the other side is called as an objective. So eyepiece and objective. The objective glass and eyepiece is fitted with a stadia, right? And you have a place mark here which is fitted to diaphragm, that is objective glass, and stadia is fitted to eyepiece so that you can adjust it. So finally what is happening is you can exactly match with your target and you can calculate the angles. Okay. So you need to remember that these two lines are called as stadia readings, right? Like we have cross bottom head, top head. This is called as top head. This is called as bottom head, and this is called as a central head, right? So we got few definitions here: centering, transiting. So I've said what is centering: setting your instrument exactly at the center so that your plumb line, right? Your plumb line coincides with the vertical axis. Then that operation is called as a centering. Plumb lines coincide with the vertical circuit, then that is called as a centering. Transiting is the method of rotating the telescope about its horizontal axis, right? So if you happen to have a horizontal axis, then if you are rotating in a vertical plane, and if you happen to write in that also, in a vertical plane, if you are able to rotate the telescope, right? This, if I am able to rotate something like this, so like if I am doing this, then that is called as a transiting, right? And what is phase length? So for any theodolite, you happen to have a vertical circle, something which is fitted to it. Okay? So a vertical circle is fitted to it, right? So if the vertical circle is towards the left hand side, so if you are watching this, if the vertical circle is towards my left hand side, then that is called as a phase left. And if the vertical circle is towards my right hand side, then that is called a phase right. What is telescope normal? If the vertical circle is towards my left hand side, then that is called as a telescope normal. If the vertical circle is towards my right hand side, then that is called as telescope inverted. What is the line of collimation? The line of collimation is an imaginary line joining with, or line of collimation, imaginary line, a line joining the points and its continuation of the crosshairs center in the diaphragm. These are the crosshairs center in the diameter, and the objective glass. The objective glass you have, right? So if this is eyepiece, then you have the objective glass. So stadia reading center and the objective glass and its continuation is called as line of collimation. Line of collimation, if it merges with the Turnian axis, then that instrument is not having any errors in it. Okay. And if you suppose to have errors, then these both are not matching. That we will discuss in permanent adjustment. Swinging of the telescope. So when you have a telescope and when you are able to rotate in this direction, or clockwise and anti-clockwise in horizontal plane, right? This is the horizontal plane, and if you happen to rotate in this direction, then that is called a swinging. We should not call rotate, because this is also rotating, this is also rotating. So this is called as transiting if you are able to rotate in vertical plane, and if you are able to rotate in horizontal plane, that is called as a swinging. This is swinging and this is transiting. So if you happen to rotate in clockwise direction, this is clockwise, right? Then that is called as a right swing, and if you happen to rotate in anti-clockwise direction, that is called as a left swing. So temporary adjustments we have discussed. We have three important steps, that is centering, leveling and focusing. So what is meant by centering? So if you happen to establish the instrument exactly upon the point which you have chosen, that setting is called as a centering. So we will exactly place our tripods above the center such that our vertical axis or the vertical plumb line exactly coincides with the ground point. That is called as a centering. Not just that, our instrument bubbles are also centered is the next operation, and that is called as a second adjustment, that is leveling. You have to make it level. Then focusing is very important. Sometimes majority of surveys notice that there is a blur inside the telescope. So you can notice that you can take a white paper, and if you have to place it in the telescope or objective, then if you adjust it, the crosshairs should be very much visible. If it is not visible, then you have to give it to the manufacturer for the service. So these are the temporary adjustments. Temporary adjustments are the adjustments which are done for the instrument before taking readings. And if you happen to calculate the angle between ABC, whatever I have mentioned here, if I happen to calculate ABC angle, and before doing this, whatever the adjustments you are doing, right, those adjustments are called as temporary adjustments. So what are permanent adjustments? So there are 5 permanent adjustments. The first adjustment is there any deviation in the bubble tube? Right? This is checked by using a capital head, which is just provided below the bubble tube. First is that. Second is whether the horizontal and vertical head are exactly perpendicular. That is the second adjustment. Third adjustment is the horizontal and vertical axes are perpendicular or not. Right? The fourth is axis of telescope level altitude bubble should be parallel to the line of collimation. Axis of telescope and line of collimation, right? And the altitude bubble is at the vertical circle, right? Near the vertical circle. All these three should be parallel to each other. And also, the fifth adjustment and final adjustment is your vertical circle should always reach 0 when I place telescope like this, right? So if I place something like this, my vertical circle should place 0, 0. Right? So these are the 5 permanent adjustments which is to be done by the manufacturer or when it gets serviced. Right? Finally, we'll talk about how to calculate the angles. Now I have a station A, I have a station B, and I have an instrument station at O. I need to supposed to calculate the angle AOB. I got 2 methods. One is repetition method, second is reiteration method. In repetition method, first we will set A station point 0, 0 and we will start calculating to B, and we will get in a something angle, let us say an example 30 degrees I have got. I'll set B as 0, 0, then I'll calculate to A. It should give the same angle. Then I will set A0, again I will calculate B. So at least 3 measurements are needed. Why 3 measurements are needed? We have 2 positions of a theory line which we have discussed here. Face left and face right. What is face left? When the vertical circle is towards the left hand side of the surveyor, that is called as a face left. When the vertical circle is towards the right hand side of the surveyor, then that is called as a face right. So if from face left you have to do 3 times, and using face right you have to do 3 times. So from face left you have to take average value, from face right 3 values you have to take average value. Mean of these average values, you got a 1 average, you have a 2 average, mean of these 2 average values will give you an angle between AOB. Right? Next, in reiteration method, what we do is we always calculate cumulative angles in AOB. For example, I'll set A as 0, then I'll start measuring angle to B. Let us say I have got 30 degrees. Then using the same 30 degrees, I'll calculate to A. I should get 60 degrees. Then again 60 to 30. 60 plus 30 is 90. So these cumulative angles, if you have done it, so I think here I have done a mistake. So you are supposed to make from here to here. This is correct. So 0 to 30, then 60 is kept to A, then 60 to 30. This is 60, this is 90. This is 60 and this is 90. So first 0 is kept, then 30 degrees. Then the 30 degrees into A, then you have to calculate plus 30 will get 60. Then 60 is kept to A, then the cumulative values you will get. And face left you have to take 3 readings, and face left you have to take face right you have to take 3 readings. And 3 readings average you have to calculate, 3 readings average you have to calculate. And from these two average, you have to take a mean, that is average, the final angle you will get as angle. So you have a practical experiments conducted how to do calculate the computation method and how to do reintegration method. We have a practical and we have certain pressure, what to clamp what, upper screw, lower screw, and all these things are there. We will discuss in detail in the next class and also in the practical.